Okay, finally a problem worthy of your talented and giftedness, right? Here's this box. It's sliding to the right. Okay? It stops, though, in a distance of 15 meters. So, of course, it's going to, it's going to accelerate to the left is what it's going to do, right? And it's already going, its initial velocity is 6 meters per second. The final is 0. And we want to know which other forces are acting on it. We have to solve for the acceleration first. So that's step 1. So displacement, initial velocity, final velocity, acceleration, time. Right? Displacement is positive 15. Initial velocity is positive 6 meters per second. Right? Final is 0. And then we don't care about the time. We want the acceleration, right? So the formula to use is v squared is u squared plus 2as. I got kind of excited there and started with the 2. Okay, so that's a u right there. Okay. And so it's going to be 0 squared is 6 squared plus 2 times a times 15. Right, so it's going to be negative 6 squared, the opposite of 6 squared, divided by 2, divided by 15. And the acceleration ends up being negative 1.2 meters per second squared, which makes sense. It's moving to the right, it stops moving to the right, the acceleration is negative. Okay? Notice that I'm making to the right positive. Okay? So that's part 1. Chapter 2, we were done, but we're not done yet. Okay, now if this thing's sliding to the right, that means that this friction force, the kinetic friction in this case, right, is actually acting to the left. So we have 17 newtons of force. Then we have some other force acting on it. I'll just be coy here and pretend that I don't know which way it is, right? Maybe is it to the right? Is it to the left? Right? The unknown force acting on it, right? Okay, and it might be 0. There might not be another force. It might be that this force causes this acceleration, but I don't think so, right? So now let's set up our F equals ma, right? F equals ma. The sum of the forces are, make your unknown force positive, right? Minus 17. That's all the forces acting in the horizontal direction. I'm ignoring the up and the down, okay? And then that equals 20 times negative 1.2. Okay, so 20 times the answer I just got, negative 24. Okay, and then I'm going to add 17 to both sides. And I get negative 7. So the force is negative 7 newtons. Now, I don't know if you knew by looking at this thing, I mean, maybe you did, that force actually was acting to the left. That there were 2 forces, right? The unknown force actually is a little bitty force there, negative 7 newtons. I don't know if you knew that, but it is to the left, and the minus sign that we got tells us that this force is to the left. Yay.